Let's say you have applied for a data analyst job in a public welfare organization, and this organization specially works for the education and health related issues of the Indian children. During the job interview, the interviewer asks you the following question. Let's say you are provided with some weight and health related data of Indian children. Now, how can you actually quantify that if the weight of the children are changing with the height of those children? If it is changing, then how the change happens and how much it is actually changing?
Now we have 20 children here and we have to quantify how much their weight changes to their height. For this, we introduce covariance. The covariance gives us a measure of how much two variables vary with each other. In statistical terms, how much the variance of one variable explain the variance of the other one. Now, to actually calculate the covariance of these students, what we have done, we have imported our data to an Excel sheet, and here in this cell, we will write the formula of equals to covariance, and we will use the population formula of the covariance here, and we will select the cells containing our first feature, that is our height, and then in next we will actually select our second feature, which is our weight, and now by closing the parenthesis we will get the covariance of 40.32. Here covariance between these two variables indicates the extent to which changes in height correspond to the changes in weight. Now if we calculate the covariance, it is 40.65 inch kg. Now the next question is, what does this value actually tell us? Positive covariance implies that as height increases, weight tends to increase as well. And a negative covariance means as height increases, weight tends to decrease. Now we can conclude that the weight of the children increases with their age, and the relation between them is very strong as the covariance is significantly higher. But let's say, what if the organization that we are working for is an US based? Then the units of height and weight will be converted to centimeter and pound, and our data and covariance will look like this. Here we can see our covariance is 227.62 centimeter pound. Now this covariance shows us that the weight will increase as the children grows, but here the covariance is much higher. Now we can encounter a question that, does calculating the relation in USA show better results than calculating it in India? This is an absurd context, right? If you look closely enough, then you may realize that this confusion is actually happening just because of the unit of the covariance. So we have to make it unitless. Thus, to standardize this, we divide the covariance by the standard deviation of both these features, and we call it correlation coefficient, usually denoted by rho xy. Thus, correlation coefficient of 0.729, irrespective of you use the data in inch kg or centimeter pound, upon closer inspection we see that even though covariance didn't have any range, the correlation coefficient has a range of -1 to +1. If the rho is less than 0, this implies that there is a negative relation between the features, and by similar argument, if rho is greater than 0, implies there is a positive relation between them. As the absolute value of rho tends to 1, the relation becomes stronger, and as it tends to 0, a weaker relation is among the features. Now, why we can't say that if rho is 0, there is no relation among the features? We will discuss this in a future video. Thus, here the correlation coefficient of 0.73 suggests that the children in the care of the organization are growing healthy and their weight is increasing with their height. We can eventually say that 1 unit increase in height will increase the weight by 0.97 unit. And how are we actually telling this? We will cover in a future video while we will discuss about linear regression. In summary, in this video we have got a high level view of covariance and its limitations. Then to cater them, we introduce the correlation coefficient and reason for its being unitless. We have also looked at why this correlation coefficient is necessary and what this is actually tells us.
Thank you for watching this video till the end and hope you have grasped the concepts discussed in this video. Feel free to share your thoughts in the comment section below and follow this series for more videos on different topics of the data world.